Hi and welcome back to DWN Academy, and welcome to this end-to-end project on air quality real-time analytics with Microsoft Fabric. And this is going to be powered by Open Air Quality APIs to bring in the real-time data from different locations to track different pollutants. So we're going to learn about this in this course, and also powered by different real-time intelligence components such as event stream, event house within Microsoft Fabric. And if you're new to Microsoft Fabric, this is an advanced course, so we assume you have some foundational knowledge on Fabric, such as capacities, one lake, and other information. And if you're a beginner watching this video, so please go through the free course we already have on the platform. So that covers the foundational concepts, and then you can jump onto this advanced project. Okay, so with that, let us get started. And a bit of introduction about me. I'm Sheikh Mohammed, Microsoft Certified Cloud Data Architect and founder and CEO of DWN Academy, and Microsoft Certified Trainer, active trainer with close to 15 plus years of IT industry experience. And I've already trained close to 500 plus students across India, Europe, and other key locations across the world. And I'm an expert in Microsoft Fabric, Azure, Power BI, and whatnot, real-time data modeling as well. Okay. And at DWN Academy, our core mission is to turn curious learners like you into confident professionals through structured real-world learning. So whatever content we produce in Academy, it is around hands-on and real-world application as well. So all the end-to-end projects we have built so far in the Academy covers real-world data and probably fits into a domain like healthcare and all. We leverage dummy data due to privacy reasons. Otherwise, we explored real-time APIs, open APIs available out there to build the end-to-end solution so that learners get that confidence to try and implement when they get deployed into projects. Okay, so let's get started. So why air quality real-time analytics and why it matters in today's world, right? So, I think air quality matters a lot due to rising health risks, due to urban pollution, a lot due to industry pollutions and other aspects as well. So there are underlying health risks involved due to urban pollution, and I think there is a need at the moment for real-time environmental monitoring. So you may have different government websites helping you to track the air quality, but I thought let us build the end-to-end solution in Fabric so that we can bring in the open air quality API data, probably with the demo of probably one location, so that you can extend it to different locations, and then you can build your own dashboard and then track the air quality in near real time. And also, I think with data activated capability, we can put some alerts if there are rising levels of air quality index. And there are different pollutants. We will quickly go through and understand those pollutants so that when you follow along this project, we'll have some idea about different pollutants and how we can derive some insights out of your dashboards. Okay. And I think traditional systems are kind of fragmented and not scalable. So I wanted to build this project end-to-end in Fabric so that you get that feel of real-time project within the Fabric. And I think at this moment, the real-time use cases are critical, I would say, and you need to leverage all of the components available in Fabric to build your real-time solution and be ready to be deployable for customers. Okay, so with that, I think let us jump on to our solution, real-time analytics solution that we are going to build in this course step by step. So be with me. So at the end of this course, you will have deployable solution, okay, tracking dashboards where you can track the real-time air quality APIs in near real time. Okay, so almost on daily basis we are going to ingest the real-time air quality index data from OpenAQ APIs, and then we are going to monitor it, and then we can put on some alerts, and we are going to build this solution and automate this solution completely end to end. Okay. So it's end-to-end pipeline using Microsoft Fabric components. So we're going to see step by step how we can do that. And we're going to ingest live data from OpenAQ API. Maybe for some locations you may not have the latest data, but I have picked one location in New Mexico in United States, so that we can leverage that live data almost coming in instantly daily, and we can see the data in action in dashboard. Okay, and we're going to look at what that OpenAQ API is and how we can set up your own API keys and bring the data in. So everything will be covered in this course. We're going to provide real-time dashboards and AQI insights, air quality insights, right? So probably you're free to choose different locations and then bring in, but the concept that I'm going to teach for one location, you can extend it to different locations and still apply the solution to different locations, and then you can build your own dashboards as well. So it is not necessarily you need to stick to what I'm kind of demoing with one location. So you can explore different locations, and I'm going to introduce you to the API so that you can build your own dashboard when you follow along this course. Okay, so I hope that makes sense. So in the next video we'll quickly look at the architecture diagram to see how the data flows from OpenAQ API through different medallion layers. We are going to build the bronze, silver and gold layers, and we are going to look at the grain of fact table, and then we are going to build the semantic model, and then finally reports and dashboards. So we'll walk through the architecture quickly in the next video. Okay, so in this video I'm going to quickly take you through the architecture diagram for our air quality real-time analytics solution. So let us quickly run through the data flow so that you can get to know how data flows from API into different medallion layers, and then into the semantic model, and then how we are building the reports as well. Okay, so as I mentioned, our data source is going to be the OpenAQ APIs. So it is open air quality API. So we are going to look at that API and see how we can get the API keys so that you can build your own solution by leveraging the APIs, different APIs available to bring in the data, not only for the measurements, the pollutant measurements, but you can also bring in other metadata as well that we're going to look at. So it is not kind of a single APIs. You have a lot of OpenAQ APIs available to bring in the location data, metadata, sensor metadata, and then the actual measurements itself. So I think we are going to leverage kind of 3 APIs probably. To the latest will bring in the sensor measurements from the actual locations deployed, so that you can look at the data that is available on daily basis, okay, for different pollutants like let's say PM₂.₅, PM₁. So if you're completely new to those pollutant types, probably I'll give you a bit of introduction in the next video so that you can be aware of different pollutants. So, and also, as I said, we can also bring in some metadata for location sensors, and we are going to leverage those APIs as well within the OpenAQ. Okay, so that's how we are going to look at. And I think the data is going to flow into event stream and into the event house. See, event stream is going to be the gateway, you can say, the data ingestion gateway to stream the data into the KQLDBs within the event house. Okay, so that is going to be our entry point or a gateway that you can think of. And I think for each and every API, we are going to build different or one event stream for one API to automate it, and then have that endpoint ready to stream the data in near real time or real time into the databases. Okay, so that's the idea. And I think inside our data landing zone is going to be KQLDB within the event house. So we're going to quickly talk about why event stream and event house, because since we are looking at a real-time use case, so it is ideal to choose the capabilities such as event stream for streaming data, and then the event house with KQLDB. So it is a perfect solution for real-time use cases. And I think if you're new to KQL, no problem. So probably we can quickly look at the basics of KQL when we do some querying with KQL within the KQL DB. But why KQL DB? It is perfectly optimized for real-time use cases and real-time capabilities. Okay, so Microsoft have introduced this solution KQL, Custom Query Language, and it is optimized well enough to handle your real-time data. And if you want to do some real-time querying of your data, that's when KQL is much efficient, I would say. Okay, so we'll talk about in the later videos probably the KQL basics, how the syntax is different from SQL, and then probably we can move on with the querying part. Okay, but we are building this bronze, silver and fact layer, the gold layer. So we are going to follow that medallion architectural pattern, and I hope most of you are already aware about medallion architectural pattern. So we are going to flow the data through bronze layer, silver layer and the gold layer, which means like the raw data is going to be ingested, the streaming data is going to be landed in our bronze layer for different locations if you're exploring, and then we are going to do some transformations and then load the data into our silver layer, and then we will build our fact table, which is our gold curated data. So we are going to talk about the grain at which we store the data into fact sensor daily table. And on top of that, we are going to build some calculated measures on top of this. So we are going to store that or persist that in another table, which is fact sensor calculation. So the data flows through different layers, and then it will be curated and stored in the fact layer. And the grain is going to be at the daily level for the sensor, as we named it, it is going to be fact sensor daily. So it is going to be at a daily grain for every pollutant, you can say, per location. So for example, if you have let's say 10 pollutant categories for a particular location, then you're going to ingest 10 different records, one record for each pollutant in that location into the fact table. So we are going to look at the grain in detail when we move on to the transformation part, or when we get into detail on those things. Okay, and we are going to build some dimension tables right within the KQL DB, so that we can build our semantic model by connecting to event house from Power BI, and then we can build those relationships between fact and dimensions and then deploy our semantic model. Okay, but the solution is simple. We are going to have this event stream gateway, and then we flow the data through different medallion layers and then prepare our fact layer, and then dimension tables will be loaded with the metadata APIs, as I mentioned, let's say location metadata APIs, and then we will build our semantic model, and then we'll be ready for our reporting and dashboarding. Okay, so we will talk about, I think it is going to be mostly the Spark, PySpark notebooks that we will build to push the data or flush the data into event stream Kafka topics. We are going to learn about different protocols in event stream, and I think which protocol we leveraged, which it's Kafka, and how are we going to push the data into Kafka topic, and how it is streaming the data into bronze layer, and the different PySpark notebooks that we are going to leverage during this course to see how we can transform the data and then load the fact table. And we are also going to leverage KQL scripts. Okay, similar to SQL scripts, we are going to write KQL scripts to transform our data. And I think we are going for the fact loading also, we are going to leverage KQL scripts. So you can get a good understanding on KQL scripts, and probably by the end of this course you will have good knowledge on how you can write some KQL queries in case if you are leveraging real-time use cases for your customers. Okay, so that's a bit about the architecture that we are going to build in this course to leverage the OpenAQ APIs and different streaming components in Fabric to derive some real-time air quality insights. Okay, so out of the OpenAQ APIs. So let us dive into the project. So with a few prerequisites, in the next video we will wrap up the introduction module, and then we will jump on to the next wherein we will try and set up the event stream for data ingestion into our landing zone, which is bronze layer inside the KQL DB. Okay, so with that, we wrap up this video, and I'll see you in the next one.